Learning target 7 says I can graph polynomials finding zeros and shape. So basically the idea of this learning target is I will give you an equation for a polynomial, and you're going to need to sketch me a graph with accurate zeros or x-intercepts. The graph should have the correct shape near those x-intercepts based on their multiplicities, and the graph should have the correct end behavior. So let's do two examples of graphs together. So the first thing that I always like to do is find my x-intercepts. So let's remember how to do that. So just as a reminder, x-intercepts are always going to be along the x-axis here, and notice that anywhere along the x-axis your y value needs to be 0. So to find your x-intercepts, all we're going to do is set 0 to be y and solve for the x's that give you that. So since the right-hand side is all nicely in factored form, I can just set each of those factors equal to 0 to find the x values that actually give me that y value of 0. So one option would be x minus 1 could be 0. One option would be x minus 3 could be 0. And one option would be that x plus 2 is 0. So from this equation I get the x-intercept 1. From this equation I get the x-intercept 3, and from this equation I get the x-intercept negative 2. Now, as you know from class, I usually like to set up a nice little table where I list out my x-intercepts, and I also list out their multiplicities and the appearance of the graph. So in this first column I like to put my x-intercepts, then their multiplicities, then the appearance of the graph based on the multiplicities. So remember, once I know what my x-intercepts are, I can use my equation to find the multiplicity of each of those x-intercepts. So for the x-intercept 1, I'm going to look at the factor that x-intercept of 1 came from, and I'm going to look at the exponent on that factor, and that will be the multiplicity of my x-intercept. So I have a multiplicity of 3 on my x-intercept 1. Next, for my x-intercept 3, I'm going to go back to my factor that x-intercept came from, and there's no exponent written there, but remember, anything to the first power is just itself, so when we have something raised to the first power, we generally don't write the actual exponent. So in this case, we're just going to have a multiplicity of 1 there. And finally, looking at our factor that x plus 2 came from, so looking in our original equation, that has an x-intercept of 2, that particular factor, so that will have a multiplicity of 2. Now, the next thing I'm going to do is I'm going to think, based on the multiplicity of each x-intercept, how should my graph look near that x-intercept? So remember, that depends on whether the multiplicity is even, if it's 1, or if it's odd and greater than 1. So the first one that we have here is odd and greater than 1. So when the multiplicity is odd and greater than 1, that's when we're going to get this sort of curvy shape. We'll get one of these two possibilities. But it's going to sort of even out near the x-axis and then continue to pass through the x-axis. Our next multiplicity is 1. So near that x-intercept, our graph is going to pass straight through. It could be sort of passing through and going upward, or passing through and going downward. And our final multiplicity is 2. So remember, any kind of an even multiplicity, near that x-intercept, our graph is going to sort of touch the x-axis and turn back around. So now let's try to put all of this together. I'm first going to put my x-intercepts on my graph, as well as my end behavior. So let's plot my x-intercepts. I have one, oops, that's not where it should go. I actually have an x-intercept at 1. I have an x-intercept at 3. And I have an x-intercept at -2. Now, before I actually try to graph this, I want to figure out what the end behavior of my graph should look like. Now, remember, the end behavior is based on the degree and the leading coefficient. So normally people don't have as much trouble identifying the leading coefficient. In this case, our leading coefficient will just be a -1. The degree is a little bit harder because in this polynomial, I gave it to you in factored form. So it's a little bit tricky to find the degree of a polynomial in factored form. But the idea is that we want to sort of look for how many x's are getting all multiplied together in total, because that will give us the highest possible exponent on an x. So right here I have 3 factors, each of which have an x in them, all multiplied together. So this part right here is going to give me an x to the 3rd as my highest exponent. When I then multiply by this x minus 3, that's another x I'm multiplying by. So now I'm going to get all the way up to an x to the 4th. This last part here, I have 2 more factors, each with an x. So when I multiply by both of those, I'm going to go from an x to the 4th as my highest degree term to an x to the 6th as my highest degree term. So the degree of my polynomial is just going to be 6. Now that I know what my degree and my leading coefficient will be, I can tell what my end behavior is going to be. When my degree is even, I know we're either going to be going up on both ends or down on both ends. And what dictates whether we're going up on both ends or down on both ends is the leading coefficient. In this case, our leading coefficient is negative, so our graph is going to be going down to both ends. So let's add that information to our graph now that we know that our graph should be going down on both ends. And now let's go through and try to fill in the rest of our graph. So after I have my x-intercepts and after I have my end behavior drawn in there, I like to just move from left to right and sort of start at this left end behavior and try to connect it up to my x-intercept in the appropriate way based on my table. Then I'll try to move on to my next x-intercept and sort of connect whatever was going on in the function to my next x-intercept, and so on. So let's focus on -2. So we knew that the appearance of the graph near that x-intercept was going to be this U sort of shape. So I'm going to take my graph and try to make it so that it sort of touches and turns back around. Like this. So next let's move on to our next x-intercept. Our next x-intercept is x equals 1. So I can see that that's supposed to make this weird little S sort of shape. So I'm going to make my function turn back around and go up and make that sort of a shape. And now let's move along to my next x-intercept. So that's at, oh no, I actually plotted it on the graph at 4, and it's supposed to be at 3. Whoops. Let's see if I can erase it. No, it won't let me erase it. So this x-intercept here at 4 is actually supposed to be over here at 3. Sorry, won't let me erase it at this point. So moving on to our x-intercept at 3, we know that the appearance there, it should go straight through. So I'm going to make my graph turn back around and go straight through. Now when you're drawing these graphs, it'll probably take some practice getting all the shapes down and sort of connecting everything properly, so don't hesitate to sort of erase and try again and try to get it to look just the way that you want it. So let's move on now to our next graph. So in this case, I'm asking you to graph f of x equals 2x squared times x plus 1 to the fourth times x minus 3. So we are going to, again, start out by trying to find our x-intercepts. And I'm going to do that by making f of x be 0 and solving for the x's that make that happen. So if you need to keep sort of writing out the little equations using the zero product property, that's totally fine. I'm just going to go through this quickly though. So from this factor, this will be 0 when x is 3. This part will be 0 when x is negative 1. And this part will be 0 when x is 0. So our three x-intercepts are going to be 0, negative 1, and 3. So now let's go back to our equation and identify the multiplicities of each of the x-intercepts. So the x-intercept 0 came from this factor here, and that has an exponent of 2, so that will have multiplicity 2. Our x-intercept negative 1 came from this factor here, which has an exponent of 4, so that will be that multiplicity. And finally, our x-intercept 3 came from this factor here, which has an exponent of 1. So we're next going to think about what does the graph look like at each of these x-intercepts. So remember, any kind of an even multiplicity near that particular x-intercept, our graph will touch the x-axis and turn back around. So for both of these first two, since we have even multiplicities, that's what our graph is going to look like near those x-intercepts. However, for the x-intercept 3, we have a multiplicity of 1, and when we have a multiplicity of 1, our graph is just going to sort of go straight through near the x-axis. So our graph will look like one of those two possibilities here. Now, when I make my graph, I'm going to fill in my x-intercepts, try to include the appropriate appearance near those x-intercepts based on the multiplicity. But I also want to make sure that my end behavior is correct. So let's think about what our end behavior should be. So to do that, we need to think about what's the degree and what's the leading coefficient. So looking at our equation, our leading coefficient is 2. And now let's think about what our degree should be. So this part here has an x squared in it. Here we have x plus 1 all raised to the 4th power. If we were to actually multiply that out, our highest exponent would be an x to the 4th. So here we have an x squared, and we multiply that by an x to the 4th. Now we're up to an x to the 6th. We multiply by another factor with an x to it. Now we're at the point where our highest degree term will be up to an x to the 7th. So our degree in total is going to be 7. Now whenever we have an odd degree, we know that our graph is either going to go up to the right, down to the left, or it'll go up to the left and down to the right. And we want to think about which of those cases this is. In this case, we have a leading coefficient that is positive, so it's going to be this situation, not this situation. So let's now go to our graph and try to put all of our information on there. So I'm going to start by labeling where my x-intercepts are. And then I'm just going to put in my end behavior. So I know we need to go up to the right and down to the left. So now what I'm going to do is I like to start all the way to the left of my graph and sort of start at my last end, and then sort of go up to my very first x-intercept and think about what my graph should look like near there. So at my x-intercept of -1, my graph should look like one of these two possibilities. So I'm going to take my graph and try to make it touch and turn back around. Now for my next x-intercept is at 0, so I want to make it sort of touch and turn back around yet again. So this is going to get a little cramped. Okay. Then finally, for my last x-intercept, it has multiplicity 1, so our graph should go straight through. So I'm going to make my graph turn back around and go straight through. So I am just going to quickly go over this graph in black so that it's a little bit clearer what our shape should be. It can be a little bit tricky to get the graph exactly right from the beginning, so sometimes you sort of have to redraw. Okay, so there you go. So that's what our final graph should look like. So let's just quickly review our strategy here. We were given an equation. We first figured out what our x-intercept should be. Once we knew what our x-intercept should be, we used the equation to come up with the multiplicities. Based on the multiplicity, we figured out what the graph should look like near those multiplicities. To figure out what the end behavior of my graph looked like, I identified the degree in the leading coefficient, and that allowed me to identify what the end behavior should look like. On my graph, I started by putting in my end behavior and my 3 x-intercepts, and then I just sort of worked from left to right, sort of trying to connect the end behavior with the first x-intercept in the way that we needed to, then trying to connect that x-intercept to my next x-intercept the way that I needed to, then trying to connect that last x-intercept in the way that I needed to as well. And then I sort of just went back over it and sort of like retraced it and tried to make it look nice and curvy and polynomial-y. So that right there is Learning Target 7.